What?
Nothing. Okay, the Leaning Tower of Pisa, it has a picture here. It has a height of 56.84, but as you can see, it's kind of slanted. It's leaning. In the 1990s, engineers restored the building so that the angle Y changed from 5.5 to 3.99 degrees. To the nearest hundredth of a meter, how much did the restoration change the height of the Leaning Tower of Pisa? Okay, so they give us this angle here. For the old one before the restoration, it was 5.5 degrees, and for the new one after the restoration, it was 3.99 degrees. We need to find the change in height. So we have a right triangle here. It's nice that they drew us a picture. We are actually going to use SOHCAHTOA for this. SOHCAHTOA. So based on this angle, we don't have the opposite side. We have the hypotenuse and the adjacent side of that angle. So that means we're going to use cosine. So to set it up, we're going to say cosine of 5.5 equals adjacent over hypotenuse. So it's going to be x over 56.84. That's the setup. Then for this one over here, same setup, still using cosine. Cosine 3.99 equals x over 56.84. Then we're going to solve this. So to start, we're going to multiply both sides by 56.84. So it'll be 56.84 times cosine of 5.5 equals x. In the calculator, and make sure whichever calculator you're going to be using on the test, you can plug it in correctly to get the correct answer. In the calculator, we're going to do 5.5 cosine times 56.84. And we will get, so the height when it was at 5.5 degrees is 56.5. I'll extend out the decimals so we're not rounding till the end. Then for this one, same process. We're going to multiply both sides by 56.84. You might not have to write it all out. In the calculator, I'm going to do 3.99 cosine times 56.84. So the height after the restoration is this, 56.7022. It wants to know the difference in height, so we will subtract those two numbers. It's going to be 56.7022 minus 56.5783. And what do we get? We get 0.1239. It says to round to the nearest hundredth, so that would be this place. So our answer is 0.12. Okay, and the next page. Let's turn it over. Okay, this one says we have a cone. It gives you a whole situation, but okay, here's the cone, here's the dimensions. The height's 15.3 feet, the diameter is 48.6. It says that there is another cone that is 3.6 feet shorter than the height of the first, but the volumes are the same. They want to know the diameter of the second cone. So I'm going to kind of overlap this so we save this space for solving. So if you had a shorter cone with the same volume, it would actually be like wider on the bottom, just to give you a visual. So shorter cone, same volume, but it'll be wider on the bottom. The volumes of these two are the same. The volume of a cone is 1/3 times pi r squared, area of a circle, times the height. We don't know the volume of either one of them. All we know is that they're equal. So we're going to set up the numbers in the equation and set them equal. So for the first one that they show us, the volume is 1/3. Then we have pi. The radius of the first one is half of 48.6, which would be 24.3. going to be squared, and then the height is 15.3. We have to set that equal to the volume of the second one. And so plugging everything into the equation, we have 1/3. Pi still stays there. The radius of the second one is what we're actually going to be solving for. We're solving for diameter, but radius we don't know. So just radius squared. And then the height of the second one, it says it's 3.6 feet shorter. So 15.3 minus 3.6 equals 11.7. So the height here is 11.7. And now we're going to do all this to solve for the radius. We're going to take some shortcuts though. If you have the same number on both sides and everything is multiplication, they just cancel out. If I was to divide both sides by 1/3, it would just cancel. So cross out the 1/3, those cancel. Pi also cancels. If I were to divide both sides by pi, it would cancel out. Now we're left with this equal to r squared times 11.7. Square the 24.3, times it by 15.3, you'll get this number, 9034.497 equals 11.7 radius squared. Divide this by 11.7, 034.497 divided by 11.7 equals this number. Then take the square root, and the radius equals 27.788. Now that's just the radius. It does ask for the diameter, so we need to times that by 2 to get the diameter. And we get 55.576. For this problem, it says to round to the nearest tenth, which would be this first decimal place. So that would be 55.6 feet, but you don't need to type feet into the box. Just type the number. And of course, make sure that number is logical. If the height's shorter and it has the same volume, then the diameter would be longer than the original, and it is. Next. Gabriel wrote a partial narrative proof to prove that FD is equal to BD. So just making a mark there, wanting to prove that. Given AD bisects EAC, so AD bisects this angle, that means that this angle would be the same as this. It says that angle FDA, this angle is congruent to BDA. And that's what it gives us. Now we're going to look at the proof and see what we need to fill in. It says it is given that AD bisects EAC. Got it. FDA is equal to BDA. We marked that already. Since AD bisects EAC, then these two angles are equal from the definition of angle bisector. It also tells us that AD is congruent to AD, and that is the reflexive property. It wants to know which triangles are congruent and why. So looking at this, there's a bunch of triangles here, but we have angle, side angle here, and that refers to this triangle right here. And the other one is, let me grab my highlighter. The other triangle, angle, side angle, is this one here. So those are the two triangles that are congruent. So when we're looking at it, that's what we're looking for. So we'll go through the answer choices. DAE, nope. DAC, no. DEF, nope. DAF, yes, that is the triangle we're looking for. So the answer is E, or wait, yes, it's E, DAF. Is congruent to this triangle. So going through the answer choices again, DAB is this triangle. Because of angle, side angle. Done. Move down here. Everybody got it down? Okay, this one, it says the population of Florida in 2010 was 18 million something, and the land area was 53,000 square miles. The population increased by 5.8% by 2014. To the nearest whole number, what is the population density in people per square mile for Florida in 2014? Population density is people per square mile, so it's like a ratio. In 2014, it said that this increased by 5.8%. So what we actually have to do is take this number and figure out what 5.8% more is. We can do that by multiplying by 1.058. Why did I throw the 1 in there? Well, if I multiply by 0.058, I would get 5.8%. But I want to know what the new population is. So by multiplying by 1, I include this original number plus the 5.8%. So that's why I did it that way. When you do that, you get this number. It is 19891785.98. That is the new population density. Or that's the new population. To find the density, we're going to divide by the square mileage in Florida, which is 53,625. And this comes out to 370.94. So in the box it says to the nearest whole number, what is the population density? So we'd round this to 371 for that first part. The second part says to the nearest whole number, how much did the population density in people per square mile increase from 2010 to 2014? So we need to find the population density in 2010. And we do that by taking the number of people in 2010 and dividing by the square mileage. And that equals this number, 350.607. We can round that to 351. Subtract 371, which is the population density in 2014. Subtract 351, which was from 2010, and you get a difference of 20. And that's your answer to B. Okay, and we're going up to the top of the next here. Okay, so the rest is actually only one problem. It's just several parts. So here's the situation. It says that we have two triangles. It says that angle B is congruent to angle D, and K is congruent to angle T, and BK is equal to DT. They want to prove this using a congruence transformation, meaning that if they move this right on top of this one, you can prove that they are congruent. It says Rashad performs a sequence of transformations on triangle BKW to map it onto DTM. Which sequence of transformations could be used to map them? Well, you would go through each answer choice to see which one works. For the sake of time and your attention, the answer is C, and I'll show you why. Okay, so it says a translation of left 10 and up 4. So you'd move each point over to the left 10 and up 4. 1, 2, 3. So B actually lands right here. And K over 10 up 4. 1, 2, 3, 4. K would land right here. K prime. And then W to the left 10 up 4. Okay, so this is where it's translated. And then it says a reflection across line y equals 3. So the line y equals 3 would be right here at literally y equals 3. And if you were to reflect this shape over that line, it would land in that spot. So that's why this is the correct answer. Okay. Next part, this is kind of a weird format. You probably haven't seen this format before. It says, use the add arrow tool to map the vertices of triangle BKW to show the translation chosen in part A. So you really had to get this part right to get this right. So what we did was we translated this to the left 10. So from B to B prime, it goes over here. K goes over left 10, and W, left 10. So you literally would draw these arrows with the program. And then you would go up 4, like we did. Draw the arrow here, up 4. And then it also says to label the new points. So this would be B prime, this would be K prime, and this would be W prime. So you would like drag and drop these over there. Okay. And the last part. Now we're filling in the blanks. These will have drop downs with answer choices. It says by translating BKW so that B maps onto B prime, and then B prime coincides with what? Well, when we reflect it, B coincides with D, K coincides with T, so T equals K, and M will equal W. So B coincides with D. The outcome of reflecting it is K coincides with T, and W coincides with M. And what are they looking for here? They are looking for congruence in terms of rigid motions. If you can move it, transform it, and it lands right on top of the other one, then it is they are congruent. Then triangle BKW is congruent to triangle DTM. And of course, make sure all the parts are corresponding. That's it.